So y'all were filling out number 1, A through I. You had a sequence, 7, 10, 13, 16. What would be the term after 16? 19. And 25. Okay. So then, when you graph it, remember if I have t of n, that would be the same thing as if I said like f of x, which is the same as y. So this was your y, and that would make the n the x, right? The input and your output. So your first point was 1 to 7. One, 2, 3, 4, 5, 6, 7. And then 2, 10, 13, 16, 22, and you can't get 25 on there. Okay, so you should have a graph that looks like this. They are not connected. It's just points. It's a sequence. There was nothing in between it. Okay, so if you have it connected, just erase in between. This is not connected. So what does the graph look like? What I was looking for here is it linear? Is it not linear? Okay. Well, it's linear. Is it a positive linear relationship?
Yeah.
What's the slope of the graph? 3. So we didn't have the y-intercept when we started, but can I use my graph to find the y-intercept? Yes. Okay. So it would be down 3, left 1. So where is my y-intercept? Okay. So how could I have calculated the y-intercept if I didn't have the graph?
So you should have looked at your chart, and then since you're adding lines from the you can subtract 1 to the 0, and then subtract 3 to the 7.
Very good. Guys, I need y'all to not be talking while these are talking. Minus 3, so you get 4. So your 0 term is your y-intercept. Very good. There you go. So write an equation, use a point, solve for b. Good. Okay, so what was the algebraic equation for that? T of n, it's okay, it's an easy fix, equals 3n plus 4. Very good. Okay, so what you guys just did is you actually wrote an explicit rule for an arithmetic sequence. So that sounds crazy, right? It's brand new, but what we're talking about is writing an equation for a sequence. So in the sequence 7, 10, 13, 16, is it possible for 200 to be one of your terms?
Yes. Yes.
How could we figure it out? I can't do 200 divided by 3. What was my sequence? What was the equation? 3n plus 4. Okay, so if I'm asking whether or not 200 is one of the terms, we're looking at this being T of n equals 200, right? It's one of the outputs, 200. Could I use my equation to evaluate this? Yes. Yes, I can. Replace T of n with 200. Okay, so 200 minus 4? 196. And 196 divided by 3 . Okay, 65.3. You can't have a 65.3 term. If you're writing a sequence, you're going 7, 10, 13, 16. We're not finding all of the individual numbers in between, right? So because this is a decimal, this is no. You don't want a decimal as a term position. Answer is no. Okay, so now I want to go back up here just for a minute and talk about some of the vocab that I've used. I said that these are your terms, and your terms are your output of the sequence. So I'll say a lot of what's the first term, what's the second term, what's the third term. The N stands for the position of the term. Okay, so if you're standing in line for something, there's a first person, a second person, a third person, a fourth person. It's the same thing with the terms. There's first term, second term. A sequence will always start with a first term. It's never going to start with your zero term is this. No. Your first term, second term, third term. All right. So that being said, let's look at number 3 down here. 5, 8, 11, 14. Okay, so I'm increasing by 3. But the easiest thing for me to do here is to make myself a little bit of a table because I need to address what is the position of the term. Okay, so N is the position of the term. What position is 5? What position in line? First. So your first term is 5. See how I left a little space here? My first term is 5. My second term? 8. My third term? 11. Okay. So you guys have already told me that my common difference or my slope is 3. I'm adding 3 for every one. I'm adding 3. So if I am writing an equation, what's my slope? 3. So 3n, and now I just need to find the zero term, the y-intercept. How do I go back? And what would that term be? 2. So it'd be 3n plus 2. Let's do it again. B plus doesn't matter what you name it, right? But the position value is always n. So we're kind of switching gears a little bit from x to n. Okay. 26. Okay, we all are jumping ahead of me, but yes, it is -5. 26 is what term? 1. 21 is what term? 2. Okay? So, yes, I am subtracting 5 each time, or plus -5. So my slope, or my multiplier by n, would be -5n. Does everybody see where that came from? Yes. Okay. So now I've got that. I need my y-intercept. So what am I going to do? Add 5. And what is it? 31. So your function, I use t of n. So t of n equals -5n plus 31. Y'all do C. So whatever letter you chose, what was your function? 1.5n plus 5.5. Very good. Okay, let's bounce over to the next page. Now, the next page has a lot of information at the top. I'm going to kind of break down for you what you need to take from this. So we're talking about arithmetic sequences today. Arithmetic sequences are not the only kind of sequence. What makes an arithmetic sequence itself is the fact that you're adding a number every time to get to the next term. Okay, there are other sequences like geometric sequences, but you're multiplying there. So an arithmetic sequence, you're adding a value to get to the next term. We call that value the common difference. All right, so 6, 8, 10, 12, 14, what's being added every time? 2. So this would have a common difference of 2. So D equals 2. That common difference we were finding on the last page, but we were using it as our slope, right? So we're spending time writing our functions, but it's still kind of slope-intercept form, right? So this serves as our slope because every single sequence, the terms are only increasing by 1. So you don't really have to spend time looking at the change in y over the change in x because the change in x every single time is 1. All right. 3, 5, 7, 9, 11, what would be next? 13, what would be next? 10. Bingo, what's the common difference? 2. 7, 10, 13, 16, 19. Common difference. 10, 8, 6, 4, 2. Common difference. There you go. 3, 2, 1, 0, -1. Common difference. Bingo. All right. Y'all flew through that. So let's look at the graph. If I'm adding the same thing every single time, if I have a graph, my graph will be linear, right? Because you're adding, right? 3 over 1, 5 over 1, -2 over 1 every single time. But if I look at my graph, it either will appear linear or you have the points like this. So I'm looking at 0 to 1. So far, so good. 1 to 4. Do those have the same difference? No. This one is not linear, and so it is not arithmetic. Arithmetic. What about 14? Yes. What is my common difference?
10.
What about 15?
Yeah.
What's my common difference? Very good. Okay. So now we're going to get into writing, evaluating, and I want to talk about the different ways first, like underneath this, that you can write the form. So we've been using parentheses, so like T of n equals 3n plus 2. This can also be written with subscript. So if I write T parentheses n, that's the same as T of n in subscript. So go ahead and write this. Subscript, it's where it's like teeny tiny down at the bottom. That's superscript. So T of n equals 3n. So these are the same, and they're going to be written in both ways. But I want you guys to understand that there's not a difference in what this is actually telling me. Okay? Now, another thing is that when we write the terms, we've been writing them in a table. But if I say, like, okay, well, the first term here would be 2 plus 3. So the first term would be 5. Everybody agree with that? And I can write it as T of 1 equals 5. The first term, because the n is the position of the term. So if I said f of 1, I'm talking about the first term. If I say f of 37, what term am I talking about? The 37th term. Okay, so the directions on the next part is where it starts talking about that subscript, which is why I brought that up now. So it says in exercises 16 through 21, write an equation for the nth term of an arithmetic sequence, then find a of 10. So the equation is the same thing that we were writing on the previous page, which is basically slope-intercept form. So I'm actually going to do the hard ones with y'all. So we're going to look at 16 and 21 together. So the first thing I need to find, if I'm writing an equation, you don't have to go back to the first page, but I'm just going to go back there because y'all are going to tell me where things came from. Where did the 3 come from here? So, the slope, or in the sequence, what else do we call it? D. The difference, yes, D, the common difference. Where did the 2 come from? The 0. The 0 term. So if I go back here, it wants me to write an equation, which means that I need the common difference and I need the 0 term. Okay? So those are the things that I need to write an equation. What's going to be the first thing that's going to be easy for me to find? That common difference, right? Negative 5.4, negative 6.6, negative 7.8. What's happening? Negative 1 point. You're so close. 2. So the D is negative 1.2. Okay. So I have the first part of my function. So a of n is negative 1.2n. I just need to figure out the second half. So I found that my 0 term, what do I need to do? Add 1.2. I'm working backwards. So 1.2 plus negative 5.4, negative 4.2. So then, how did I get 4.2?
Yes. You have to go find the line.
If I put these back in the table, I'm going back to the 0 term. This is the first term, second, third, that's 0. Okay. So here's my answer. Now it says find A of 10. What is A of 10? The 10th term. So if I have A of 10 and I have this function, where am I going to put 10? Is it the input or the output? Input. I replaced N with 10. It's the 10th term. This is the position, right? So this would be 10. I shouldn't have. Does that make sense? Yes, that's all. So I'm replacing that with 10 because we're looking for position 10. So negative 1.2 times 10 minus 4.2. Yes, of course you can use a calculator. Negative 12 minus 4.2. So negative 16.2. So here
7.8.
are your answers.
What is the 10 from?
They asked for find A of 10. So they're asking us to find the 10th term. Jason, put that phone down.
What?
Thank you. Oh, okay. All right. Let's do another one. That was a lot of work, but let's do it. All right. So looking at number 21, we need a common difference. We need a zero term. 9/4, 7/4, 5/4, 3/4. What's my common difference?
Minus 4, which is 4.
Minus 4.
Minus 4.
Minus 2/4.
So that's 1/2.
Negative 1/2. Very good. So my common difference is negative 1/2, which means I can start my equation over here with negative 1/2 n. Now, got half of it, let's get the other half. I need my zero term. What should I do to find my zero term? Add a half to 9/4. So 2/4 plus 9/4.
11/4.
11/4. So here's that. So I have A of n equals negative 1/2 n
Plus 11/4.
plus 11/4.
We want to simplify or no?
You can't simplify 11/4.
You can't. No, like, only allowed.
I would expect you to, if it can be, but that can't be. No mixed numbers.
Okay, so it can't be like
No.
2 and then 2, like 3/4 or something. Okay, so if it can't be just a whole number, then just do it as a fraction.
Yep. Okay, I'm not done because the directions also want us to find which term.
So it's gonna make sense.
The 10th term. So I need the position to be 10 and evaluate. Well, what's half of 10?
5.
5. Now here's the fun part. 5 plus 11/4.
5 plus 2.
What divided by 4 gives me 5?
What?
20. Oh, 20. So it's 5.
So negative 20 plus 11.
Wait.
Over
How'd you get rid of
It's
20?
31 over 4.
Wait, what? I want to say
If half of 5, if half of 10, if half of 10 is 5,
Negative 2/4.
I got it into common denominators. So times 4 times 4, so that I could. You also have a calculator, so you could have just done negative 5 plus 11/4.
So that's how you
So negative 20 over 4 plus 11 over 4. Negative 9 over 4.
9 over 4.
That's good.
There's your two answers. Okay, now keep in mind we did the hardest ones together. I want you guys to now do number 20 for me. All right. First thing, A of n equals
61.
3 and
Oh, 3 and plus 3.
and then A of 10.
61.
Very good. Okay. So now, the next part, determine if it's linear. Determine if it's arithmetic. If it is, find the common difference and write the formula. All right. So we're going to look at together 3 and 4. Now remember, we already looked at the graph. How do we know if it is arithmetic? If it has a common difference, right? So 8, -2, -12, -22, is that arithmetic? Yes, it is. What's my common difference? All right, and now we need to write the formula as a linear function. So A of n, the whole time, get used to it. A of n equals n. Do I have my next piece yet? No. What do I need to find?
You have to find 0.
The 0 term, I have to add 10. 18. So -10n plus 18. Very good. No. It just says find the common difference and write the formula. So you're done. Okay. Number 4. Is there a common difference there? It's not times 10 because we would be adding a 0. And also that would make it geometric, not arithmetic. So no, it's not. That's it. Okay. You guys are going to do 7 and 8. Okay. 7, arithmetic or no? Yes. What's the function?
And plus 81.
There you go. Okay, 8, yes or no?
Yes.
No.
Okay.
There's no
So, time out. One last piece and then I'll pass out the wipes. Okay, this is the arithmetic sequence as the equation, but they've just reversed the slope and the y-intercept. It's still the same thing. How would I find the first couple of terms?
You add 10, 37, right?
Yeah, well, no, you subtract 10.
Subtract 10.
You're plugging in 1, right? So my first term, 37 minus 10, would be 27, right? What would the next term be?
17. 7.
Why is it, how did we figure out that that's the route we're going? Because what's the common difference? Minus 10. So your common difference is here. All right? Put that down. We're still on notes. I don't know why we're packed up. The last part. Given the first term and the common difference, write the rule. So A of 1 is 20 and the common difference is 2. What do I know from my sequence or from my rule? What can I already build? Where are your notes?
You have the difference.
Okay, so where can I start it? 2n. Good. Am I going to put 2n plus 20?
No.
No. I need to find A of 0. Well, if I add 2, what do I need to do? 18. Very good. Okay, so you do not have homework. We're gonna continue with this on Monday.